This could be the most perfect setup for a freeze dryer. Plenty of room on this side, nothing to obstruct the airflow. Plenty of room on this side. Once again, nothing to obstruct the airflow. This is my dining room table, 76 degrees, low humidity. It would be a great place to put it if we didn't want to have to worry about eating as a family. If you're like most of us, however, we can't be this lucky. Most of us have our freeze dryers tucked away in basements and garages and in corners of rooms. So the question is, what is the best setup for a freeze dryer? And most importantly, is what about clearance between walls, freeze dryers, and vacuum pumps? This video is going to take a look at the clearances of the vacuum pump and freeze dryers and the effects of heat upon them. The tools we're going to use to review this issue are going to be a thermal imaging camera and an infrared temperature sensor. My freeze dryer and vacuum pump are at the end of a hallway in my house. The hallway is 36 inches wide, the same dimensions as you see here. So what I created, I took a couple of pieces of drywall on this side and this side and put the same widths as I normally run my freeze dryer. And what we're going to take a look at is the amount of setback between the freeze dryer and the wall here and the freeze dryer, the vacuum pump, and the wall here, to see what is the best clearance that a vacuum pump and the freeze dryer should have, so that we don't have radiated heat bouncing off one wall and reflecting back upon the vacuum pump and the freeze dryer. There's very little information that Harvest-Right provides about how much distance should be between a freeze dryer, vacuum pump, and a wall. Currently, right now, in my setup, I have 4.5 inches between the vacuum pump and the freeze dryer, and 5 inches between the vacuum pump and the wall. On this side, I have 3.5 inches. Anything that runs off electricity can generate heat, and this is the same for these two appliances. The freeze dryer generates heat from the compressor that's on the other side of this grill. The vacuum pump generates heat primarily from the motor behind and the pump in front. Both of these generate heat and will transmit that heat through basically radiation. The heat will radiate into the air or to the nearest surface. So the same thing is here. How much heat can a standard wall take before that heat is absorbed and radiates the heat back out? Although your freeze dryer can be placed just about anywhere in your house, the vacuum pump cannot. The vacuum pump is literally on a leash to the freeze dryer. The vacuum pump can only be moved so far away from the freeze dryer. Technically speaking, the vacuum pump can either be placed to the side of the freeze dryer, below the freeze dryer, or in back of the freeze dryer. And I guess if you really wanted to, you could place it on top of the freeze dryer. You could make a longer hose for the vacuum pump, but since the JIC fittings that Harvest-Right uses incorporates an O-ring, which is pretty much a proprietary part, making your own hose, which is longer, may not be the best thing to do. But it's possible to do. First thing we're going to do, we're going to take some baseline pictures. This is where the... Alright, hold on now. This is my own video and I'm already bored. So let's just cut to the chase and get to the results.
Before we start, I have a little bit of a disclaimer. This research I did with the setbacks and the temperatures was with the original vacuum pump that came with my freeze dryer. If you have a premium vacuum pump or the oilless vacuum pumps, the setbacks are probably still somewhat valid, but I really can't guarantee the temperature ratings and the distance because I used a standard run-of-the-mill vacuum pump. So with that being said, let me show you what I found. Some pretty interesting stuff. First setback that I want to discuss is on the left side of the machine, which is right here, and that should be 4 inches or more. Basically anything less than 4 inches here, you're going to cause a little bit of turbulence as the air comes through the condenser and through the fan and out the other end over here. So keep it 4 inches or greater for the left side of the freeze dryer. Now for the right side of the freeze dryer was probably where the most interesting measurements I came up with. Basically, it should be 4 inches on this side. The reason is quite interesting, and we're going to cover that. What I found is that as air is flowing through this side of the freeze dryer from the condenser fan and blowing over the pump, and then you have air coming along the side of the vacuum pump, because back here on the back of the vacuum pump is where the fan is located, and the air is blown from rear to the front of the vacuum pump. And so basically this is almost like a symbiotic relationship with the air flowing this direction and the air flowing that direction. They both help each other in keeping things cooler. And by putting everything at 4 inches between the vacuum pump and the freeze dryer, I found it cooled the vacuum pump by 5 degrees less than the vacuum pump standing alone, if that makes sense. One other thing I found out is regardless of where the vacuum pump was in relation to the freeze dryer didn't really care what was next to it. Now, the real interesting thing is how far away the vacuum pump is from the freeze dryer. And basically, between 4 inches and 12 inches is where the vacuum pump received the greatest amount of heat. I think what happened is once it got too far away from the freeze dryer, that the air blowing out of the freeze dryer here at 12 inches wasn't enough to get to the vacuum pump to help cool it. So between 4 and 12 inches, there was actually an increase in the temperature of the vacuum pump. I found that pretty interesting. But the best setback for the vacuum pump I found is 4 inches. The last setback we need to discuss is going to be on the right side of the vacuum pump, which in many cases is going to be somewhere near a wall over in this direction. And what we're looking at for this measurement is 9 inches to 12 inches or greater. Anything under 9 inches in this area here is the heat coming from the vacuum pump going onto a standard wall will heat up and reflect the heat back onto the vacuum pump. At 12 inches and greater, there really isn't any problem. Now, if you're in a basement where you might have a cinder block wall or concrete wall, those walls will pretty much absorb all the heat in the world without the heat ever reflecting back onto the vacuum pump. So there you have it. I hope this helps you. I hope it gives you some information to go on. One other thing to make note of, if you're going to use a fan on your vacuum pump, don't put it above the vacuum pump, don't put it to the side of the vacuum pump, but put the fan directly on the back end of the vacuum pump. So what you're doing is you're increasing the velocity of the air from behind the vacuum pump going into the grill of the vacuum pump where the fan is here, and then blowing along these ribbed sides. So if you're going to use an auxiliary fan, put it directly on the back of the vacuum pump, and that is where I got the biggest bang for my buck. If you enjoyed this video, please give me a like and go ahead and subscribe. Thank you.